I think Sunita and Kirk have talked a lot about the problems that India is facing, and what I'm going to talk about is some of the tools that we've used in the U.S. that may be applicable here. Again, I'm Phil Dickerson with the U.S. EPA, and I am not a scientist, I'm actually an engineer. So what you're going to see today is a lot of tools and ways to use science. I've always thought the difference in scientists and engineers are the very practical appliers of science. So that's kind of where I'm going with my presentation. I'm going to throw a whole bunch of things at you because I wasn't quite sure exactly what you'd be interested in. So each of these is a little bit different, but it's all kind of tied together by a fabric of public information.
2 minutes, then
sure.
We still have 10 minutes for some questions.
I will do that. Okay. So I'm first going to talk about AirNow, which hopefully folks have seen at airnow.gov. And what we did there is basically starting in the early 1990s, people started trying to map air pollution, which was a pretty bold concept then because we didn't have the World Wide Web and the rise of the internet. So people just didn't really know what air pollution looked like. And then the EPA Region 1 in the Northeast US actually took that project and expanded it to their states. Then myself and a team from the EPA headquarters actually took that system and made it a national system in about 1997. By 1998, some of the agencies we were working with were no longer happy with just showing what air pollution looked like, but they wanted to actually try to predict upcoming air pollution. So we started carrying forecasts. By 2007, almost 10 years later, we had all 50 states actually submitting data and forecasts to our system. So then in 2008, we actually started to get interest from other countries about how they could replicate what we had done and started working with Shanghai, China to help them set up an AirNow system in that province. So today we have year-round, 24-hour-a-day, 7-day-a-week coverage of real-time data for all 50 states, Puerto Rico, the Canadian provinces, and even some of the national parks. We have next-day forecasts for over 400 cities. In the summer, that's because of ozone and PM, and 300 cities year-round. That's just PM25. We also have built apps for the mobile phones, and we have a lot of state-of-the-science information about air pollution health effects so the public can read about what all this means for them. We've also been able to develop some partnerships with media outlets to get this information out on the traditional media. So the main elements of our system, we monitor and acquire data. Then that data flows through the system. We also have an analysis portal called AirNow Tech. And then there's forecasting and a community of people that make all this work. So I'll go through this quickly because you've probably already seen this before, but monitoring and acquisition of air quality data in the US, EPA provides grant funds to the state and local agencies, and they actually operate the monitors. So those agencies are responsible for the monitoring and quality of their data. They report that data to EPA's air quality system, or AQS, and that's where all the regulatory decisions are made. So that's an important difference in AQS and our AirNow system. AirNow is completely voluntary, and we have pledged not to use our data for regulatory decisions because it's coming in real time. We're getting data from about 1,600 ozone sites and 1,150 PM25 sites, and there are still 380 PM10 sites coming in. And then again, we have forecasts that are submitted by our local agencies. EPA doesn't determine the forecast, the agencies get to do that. In terms of some of the outputs, all this data comes in, and then what we do to add value is create a quality assured national data set. So all the data comes into AirNow, and then we redistribute it back out to the public via our website and our media partners. And it also goes back out to the state and local and tribal agencies, and even gets used in research occasionally. So what we're doing here is, when the states first came along, they wanted to see other states' data, and that turned out to be an important thing in terms of air quality control. The states like to compete with each other, so states wanted to see what was coming from other sources, and it also helped in forecasting. AirNow Tech is a system that is not publicly available, but you can request an account. And what it has become is a decision support system that's kind of anchored on this real-time data. It has a lot of GIS functions. You can do trajectories, so you can actually see which way the air masses are moving. You can do data queries, create your own personalized tools, preferences, and services, and you can overlay all this data on top of each other. So what you're looking at here is a map of aerosol optical depth, which is a satellite measure of particles. And you can overlay this on top of all sorts of other data sets to start to get some idea of why a particular measurement might be what it is. Forecasting very quickly. The state, local, and sometimes city officials submit the forecasts, and I always have to make the point, we do not do the forecasts, we only accept the forecasts from the participating agencies. So they get to determine the forecasts themselves. And they do that in a lot of different ways. There are all sorts of different models. And then we distribute that forecast that's provided as a national product. We provide some forecasting support. The AirNow Tech system that I just mentioned has a lot of tools to help forecasters come up with their forecasts. And we also have our NOAA, the weather agency, providing model output from an air quality model that they run. There are a lot of resources for forecasters on our website, and we also have a forecast verification system to see how good the forecasts are. The community that we've built to keep this thing running, we actually have webinars. So if you go to our website, you can see that we have a webinar series, and we invite folks from all over the world to do presentations. And we try to have these in times that are convenient for Asia. So usually I'm up at 10 p.m. doing the webinars in my pajamas before bed. We have program and technical topics. We have a community news segment, and here you see a list of some of the webinars that we've done so far. The purpose here really is to try to get people to share experiences and ideas. The different types of members of the community, we have operating partners. These are actual regions that run the AirNow software, exactly the same software that we're running in the US. And then we have partners such as Canada and Taiwan that are submitting various kinds of data to the system. And then we have a lot of support organizations that are behind the scenes kind of keeping this all going. So if you want to join us, this is a screenshot of our AirNow community webinar, and I have that on the resources at the end. So in terms of challenges and future plans, this starts to get into the exposure. I'm sure you've been wondering when I was going to get to that. So citizen science is one of the big challenges that we're facing at EPA, because there are a lot of low-cost sensors that are coming out, and we don't really know a lot about their quality and reproducibility. So we're trying to get a handle on that and then see what we can do with this new, very low time resolution data. We want to encourage data sharing in Southeast Asia, try to replicate what we did with AirNow with the states in the US. We're going to move more of our system into the cloud to make it easier for smaller countries to adopt and less costly to try it out. And then we want to continue to explore the fusion of satellite air quality data with ground level monitoring. I won't go over this very much, but the NowCast method is a methodology we came up with to help the public get an idea of what's going on with PM 2.5, and we came up with this in conjunction with the State Department for Beijing. And what it basically is an average of the previous 8 to 12 hours, and what's different here is we actually weight the NowCast based on how quickly air quality is changing. And what this does is, in the US, we have a 24-hour PM 2.5 standard, so it takes 24 hours for you to get that regulatory number, which is far too late. So what this is doing is trying to give you a number that is more time relevant and not waiting the full 24 hours. Yet we did enough data analysis on this that we portray the NowCast as kind of an AQI substitute for real time. So you still get the health messaging, and you get kind of an early warning. You may have heard we recently just signed an agreement with the Department of State to host the data for their embassy monitoring program. This is a screenshot. There are 5 sites reporting in India right now, so this gives you access to State Department data that's measured with EPA instrumentation and methodology, so it gives you kind of a point of comparison. So then satellite data very quickly. We basically, the satellite sees a lot of places that are not monitored, so we've been trying to figure out how can we use that satellite data and integrate it with the ground level data to get a better picture of air quality in rural areas. What you're seeing here is essentially we took satellite aerosol optical depth, combined it with observations from AirNow, chose the data point that had the highest certainty for each cell in this map, and then called that our fused product. So this particular example, you can see the observations are missing a large area of orange and red PM that the satellite sees. When we fuse that together, we get an idea that there's actually something going on in that area where there are not very many monitors. This is just a map of the continuous ozone and PM monitors to show that while we do have a very dense network, there are very large areas that have virtually no monitoring. And this is an estimation of kind of the areas that don't have enough PM2.5 monitoring to give a good exposure metric. And I will skip over this in the interest of time, but essentially this is how we fused our satellite data and chose the data point that had the highest certainty. And this is a screenshot of our AirNow satellite data processor. These are all the sub-products that go into this satellite estimation. And again, another case study. These were wildfire complex in Colorado that were pretty far outside the traditional monitoring network. And you can see the satellites saw a lot of PM there that the traditional network did not pick up. So now the next generation air monitoring. So traditionally, air pollution's been measured by expensive, very stationary and complex instrumentation. So EPA has started the next generation air monitoring project. What we're trying to do is look at apps and sensors for air pollution, mobile monitoring, passive fence line monitoring, enhanced national ambient air quality standards, satellite data, and data fusion. So this is just a brief flow chart. Basically, as you can see, the new paradigm is handheld small sensors that are used by communities and individuals and result in a lot more data points that are a lot closer to where you're actually breathing. One of the ways we've used sensors is the Village Green project. Our Office of Research and Development actually built a park bench that has a set of small sensors inside the bench, and people can actually come up and sit on the bench and then look at the readout and see what the various pollution levels are. They made this an open grant proposal, and there were 5 sites that were selected, as you see here. And all of these are up and running, and the data is actually coming into our AirNow system. These are pictures of the 5 sites. You can see what the bench looks like. It is solar powered, so it doesn't need any external power. And this was the first winter in the US that Village Green was in operation. A couple of the sites up in the northern part of the country actually had a little bit of trouble having enough power because of the lack of sun, but they're working on that. And this is a shot of the bench on the inside, and you can see it has essentially a power module that stores the solar energy and then a series of small instruments. So the initial assessment in Durham, North Carolina, which is where I'm from, indicated agreement within about 15% with a nearby reference instrument for PM2.5. Ozone from the Village Green monitor and the reference monitor have also been in close agreement. And PM2.5 had a pretty good agreement in April and May. I mean, not as good in April and May, but very good in June. So the data is actually tracking fairly well. And this is the AirNow website where the Village Green data is available. This is the first time that our AirNow system has had 1-minute data. So we had to do a lot of work behind the scenes to change our paradigm from 1 hour to 1 minute. And the public can actually get the 1-minute values from all of these 5 stations. And they can graph and see it on a map and do a lot of different things with that data. The other thing we're working on is now that we have these small sensors, EPA always provides a health context with our air quality index, so we're trying to figure out how to provide a health context for what people may be measuring in the palm of their hand with a 1-minute value. This is actually pretty challenging. So we did some focus group testing with the public, and they indicated they would like a high, medium, low type message. So the breakpoints and messages would have to be based on our understanding of broad body of health evidence and should consider what population we want to advise and how early we want to tell them to do something. So we came up with breakpoints and messages to minimize, basically, we wanted to have low messages when the AQI indicates that the air quality concentration is unhealthy and high when it mentions that it's in good. This is our draft approach for PM2.5. This actually just came out last month, so it's brand new. So basically, we have a message for when the sensor doesn't seem to be working, and then we have low, medium, and high. And these are the proposed breakpoints. We are analyzing data, but there's not a lot of 1-minute reference PM data out there. So you can see these messages are not truly health-based because we don't have the health science that we use to create our national ambient air quality standards, but they're more about avoiding exposure. So at high, it actually says you might be near a source, and then you should move and check your reading again. And this is an interesting difference in traditional monitoring. You might actually be able to move and reduce your exposure depending on what you're standing next to. And then ozone is very similar. And this is basically how we're going to go public with this. We're going to release a prototype mobile app that will allow people to put in their sensor messages and put in their sensor values and get these messages. And we'll also display those Village Green stations that we already have out there. This is my last slide, so I think I almost made it. So resources for further study, our airnow.gov/international page has the community that I talked about. And then I've left a couple of links about small sensor activities that we're undertaking. And I'll stop there.
Thank you.